All right, today we're going to start another part of our river unit, our lesson 6 about weathering and erosion. If you recall from the other day, we did talk about headwaters, meandering, different terminology for the last lesson. Here were our pictures matching up with what they were. We're going to need some of this information to help us figure out what we are going to learn today. Now, if you look at this picture right here, you can see you have a nice grassy field, you have a river flowing, but then along the edges here, you can see this jagged part of the soil, not a straight line by any means. The river's flowing along the way, and we asked the question here, what actually is happening here? What are some signs that the river is being destructive? And ask yourself that as you're looking at this. What you should be saying in your head is, well, I noticed right here there's a bunch of grass. Well, that grass and that dirt used to be connected right up here at the top, but the river, as it was flowing by, started to wear away at the materials to a point where the materials underneath fell into the river. Well, that weathering, the breaking down of the particles, and then once it falls into the river, the erosion will cause the materials, that erosion part, to be flowing downstream. So the first question on your worksheet, lesson 6, says, what's the difference between weathering and erosion? Why don't you pause the video right now? Make sure you answer that question in a couple minutes. Here is what you're going to need to add into your notes, and then answer the question, I'm sorry. So add this into your notes, then pause the video, and then answer the question on the worksheet, the difference between weathering and erosion. And make sure that you really take your time and do a nice job writing good, complete sentences that really explains it, because a lot of times people mess this up. They mix up weathering and erosion, and they use the wrong terms. Weathering is the breaking of the rocks or breaking down of the soil. The erosion is when it takes those pieces, those sediments, and carry it away. So why don't you pause the video right now at about 3 minutes and then answer question number 1. Now, question number 2 asks you to come up with 3 ways that wind, water, and ice can actually erode the materials, carrying them away. Well, the first box is the wind. Well, wind, if you can think about this, is when wind blows around and it picks up materials. An example that I see in the spring and in the fall is when I'm driving home, I see the farmers out in the fields and they're plowing, and there's always a big cloud of dust behind them. And that dust are just pieces of soil that get kicked up in the air, and the wind carries those particles away. Another example might be sand dunes. Sand dunes in Michigan and Indiana, deserts. The wind picks up those particles of sand and carries them and drops them off someplace else. That's erosion by wind. So in that box, why don't you pause the video here in a second or two and draw an example of either the farmers with the fields, with the dust being blown away, or maybe an example of a sand dune. So spend about 2 minutes or so drawing a nice picture for that. Now the second box, that's showing how water can carry things away. The first picture of the slideshow here, that had an example of water eroding materials. You can see the water was kind of brown. This picture right here on the slide shows an example of how water weathers rocks, but it also shows how it's eroding it. It takes all of these pieces that were here and carries them away. At one point, it's hard to believe, but this was filled with rock, and this little stream, 10 feet wide, 15 inches deep, wore away this V-shaped valley. And they call it a V-shaped valley because only the center part gets worn down. It carves out this channel, this V-shaped valley. The last one, you can turn to page 145 if you want, or you can listen along. So now that you've drawn your picture about how water can erode land, the last one is ice, and that may be talked about if you looked in your book on page 145. Another way that it can move items is through ice. And try to ask yourself this question: how can ice move rocks? How can ice move rocks? Well, the simple answer there is to get to the answer is to think about mountains. They have large blocks of ice on the side of the mountain that move down the hill. Those large mountain or blocks of ice are called glaciers. Glaciers themselves are just huge, massive chunks of ice that gravity is pulling down the hill. And as gravity pulls it down the hill, that ice runs into rocks, runs over rocks, crushes rocks, encompasses rocks, surrounds it. And they carry these rocks downhill. In a couple days, we're going to show you some things called unsorted sediment. And these are these huge boulders the size of our classroom that are in the middle of a plain at the bottom of a mountain, miles from the mountain, and they try to figure out how they got there, and it was by glaciers. Glaciers carried them there, and then over time glaciers decided to, they melted, and they retreated back the hill to the mountain, leaving the rock behind because it couldn't carry it. So this animation that I'm going to show you right here just kind of just shows, to answer question number 4, why would a river want to have to change directions? It comes up to this idea right here. Let's see if I can find it. That's not it. That's not it. This one right here. It might run into a material that's a little bit harder, like our igneous rocks we talked about. They're made out of crystals. These crystals don't erode very easily, whereas sedimentary rocks do erode quite easily. So this animation right here shows all of these igneous rocks out here, and the layer that keeps on getting worn down here in the middle, that's sedimentary rock. Wind and water wear that away. Notice that goes away, but the igneous rocks don't. They stay right where they are because they don't wear down nearly as fast. So the next idea, actually we can go back to question number 3 if you take some time and pause the video after I'm done talking. How can water become a destructive force? You have to ask yourself, how can it wreck land? I think you should be able to answer that pretty well. Question number 4, why would a river have to change direction? Well, it would have to change direction because it ran into something that it cannot go through, or that it cannot go over, or it's traveling downhill, not uphill. Now, if you turn your paper over after you fill in that answer, question number 5 says, what does the process of cementation do? Well, add these into your notes, these notes into your notebook. Compaction versus cementation. Well, compaction is when layers fall because of gravity, and one layer falls on top of another layer. That gets a little squished together, but then another layer falls on top of that, and that gets squished together a little bit more, and then another layer, and all of that weight squishes them together. That's called compaction. I use the example in some of my other classes of the garbage can at home. I'm lazy, I don't like to take out the garbage, so what I do is when the garbage gets to the top, I take my big foot and I stick it in the garbage can and I squish it down, and I make a compacted layer. And then we fill it up again, and then I take my foot and I compact it down, and then I do that 3, 4, 5 times, and now the bag is completely full. It's got many layers of garbage, and now I can take, or I don't take it out, I'll have my kids take it out because I'm relatively lazy when I get home. So I want my kids to take it out, so they'll take it out. Now that's compaction. The question number 5 says, how does the process of cement, or what does the process of cementation do? Well, when those layers get compacted and water gets mixed with it, because water is the thing that carries these particles around and drops them off, the water carries minerals. Well, these compacted layers are squished together, but there's still spaces in between the particles. So the minerals in the water then go and fill in those little gaps, and the minerals then cement all those particles together, actually making that sedimentary rock. So what does the process of cementation do? It's right here in your notes. After, over time, those layers have been deposited and they get squished together and compacted. Well, cementation is when the minerals in the water go between those sediments and they stick them together and form that sedimentary rock. So that's kind of how, what happens with cementation. And the last question asks, how does compaction occur naturally on Earth? Well, that in itself is answered just simply by the idea of gravity. We talked about that just a few minutes ago. Gravity causes things to fall in layers. Those layers then stack up on top of other layers, and gravity squishes those together, and then gravity puts another layer on top, and then that squishes that together. And it keeps on working that way all the way over time, compacting layer after layer after layer with weight after weight after weight of materials, squishing it together. It creates that compacted layer, which then water and the minerals in the water cement them together to make the sedimentary rock. So I think that would answer that one. Please make sure you turn that assignment in before you leave. We will have time left at the end of the class here. What you should do then is go back into your Google Classroom. I put in the slides for all the things that we've covered so far. Go through your notes, add things, do some review, quiet, independent review for the rest of the class period. You may want to go back into your book and read the section that deals with weathering and erosion, or reread that section. So any other questions, please do not hesitate to ask. This worksheet that you had in class is due before you leave. Thank you. Have a good night.